Hello, this is Jens from SecurityValley, and this is the next video for the SecurityValley CTF write-up playlist for YouTube. This time the write-up is maybe a little bit different from the others, because I want to show you some things that has happened behind the curtain during creation time of that challenge. Yeah? But first of all, as usual, I'm logged into ctf.securitywalley.org. Have set here the categories filter to network and open the malicious traffic, and then the link here will lead us to the GitHub repository. And we start super simple by download the file, then open the file in Wireshark, and I think, or I guess that the UDP DNS data flow that you have seen here should be familiar to you, because you have mails, try to solve the challenge. What you see here is a standard query for a TXT record to the specific domain here, and sometimes, or as usual, get here some DNS answers from that server here. And you see sometimes in the TXT record or in the TXT query there is a subdomain that looks a little bit gibberish here with the 0xAABG to that specific domain that we have seen during the start of the flow here. Then another byte packet or another series of bytes, and then another series of bytes. And if you look to the three packages here, and the three packages here, you see they have something in common, which is the start, which is 0xAA, and the end byte, which is 0xFF. And you see the exact same order in those three packages here, which is 0xAA and 0xFF. So what does that mean? To understand this, I have prepared a short or small diagram where we need to talk about. What you see here on the right side, where the CLI and the attacking infrastructure is drawn, this is part, or the whole blocks or parts that you see as part of an offensive framework that I've written so far. It's called the Queen, and we're gonna investigate that in a couple of seconds or minutes. But first, we need to talk about the four essential parts that we need here. So the first thing is the CLI, which you, as let's say it as a hacker, are connected to your command and control server. And the command and control server has three types of listeners that can be exposed to the world or can be exposed to a redirector to not expose your command and control server directly to the internet or to the public. And the framework has three listener types. One is DNS, one is HTTP, and the last one is TLS. And it's a little bit comparable, familiar if you know Cobalt Strike. That looks maybe a little bit familiar to you. And then you have the implant, which is the malicious part, the malicious exe, call it whatever you want, which starts an initial pull loop. I think the initial time was 45 seconds, but we're gonna decrease the pull loop in a couple of seconds if we start infecting the device. And for our example, we're gonna set the transmission mode to DNS. And therefore, let's boot up the command and control server. So I therefore switch it to my terminal, and if you see, this is the command and control server, which have we seen so far in the diagram. Then I have started the CLI. As you see, Jens has joined, which is my user, and if you have seen, or what you could see in the diagram, you can join with multiple users here to have your hacking party or whatever. And then we need to build the malicious piece of code. So therefore I've created a builder, which is written in Go, and do some pre-linking, pre-compiling stuff magic under the hood. And what you see here is that we have two essential command flags here, so to say. The T is for the transmission mode. We have set that on DNS, and the name, let's call it a Netflix cracker.exe. Why not? So let's run the command. then you see the Queens Builder start to bundle all your stuff together, do some obfuscation, yeah? All that you need to evade or bypass the antivirus. And we have seen, or I have set here the platform to Windows. So let's start by copy and paste here our fresh created malicious exe file to my VirtualBox or VM share folder. And then let's see what our Windows machine can do here so far. So this is a fresh installed Windows 10 machine with the latest updates, but we can check that. Yeah, so the the Windows operating system here is bleeding edge with the Windows updates, and we look here at the Windows security, and the only thing that I have disabled here, if we go to manage settings, is the automatic sample submission. Yeah, so I don't want to burn some code, cause this is not intended to spread in the wild. Yeah, this is for local testing and malware engineering or analyzer stuff. So therefore I have disabled the sample transmission. And we also look at the Windows firewall. I think there's that stuff here. And sorry for the mix between maybe German words here and English words. But the thing here is that the Defender firewall is on or enabled for domain, private and public profile. So if we look back to our diagram, just give me a second. What we're now going to do is let's skip the infection stage, yeah, where you normally do your phishing, social engineering, whatever, and assume that with some magic the exe file was downloaded, moved to the infected to our prepared Windows machine. So, and what we're going to do now is we start the malicious file and hope that the Windows Defender and all the other protection mechanics are getting bypassed. And then we assume that we see like I'm here message in our command and control, or to be more precisely in our command line interface. So therefore this is the command line interface. Our command and control server is up and running. So therefore let's switch back here to the Windows machine. Open here the share folder. Here's our Netflix cracker. Send it here to the desktop. Let's wait 1 or 2 or 5 seconds. Nothing appears from the antivirus system so far. Let's quickly do a scan here with the Microsoft Defender. If you can see something what pretend to be malicious and everything looks fine, then we can start the file. And we see, I quickly move the VM here to the right screen, and we see that we have an incoming request to our server. So in order to communicate with our infected device now, you see here we have kind of a session config, and we need to set that subdomain name here as a session. And the first thing we're going to do is with the PCMD, that is an abbreviation for publish a client command. We want to set the initial sleep time, so that means the pull loop to our command control server to 10 seconds. That our traffic is a little bit more verbose, so to say. That means here our command was successfully processed from the implant on the infected device. And now we can open up here Wireshark on the machine, then go to the Ethernet 2 here, cause it's a host-only network, and let's set here the filter to DNS I think the keyword input is wrong, sorry. So DNS and UDP, and then we need to wait a couple of seconds and look back in the meantime to our command and control server. So that means at this timestamp our implant has said, okay, I have understood that you want to decrease the time loop, and now we should see every 10 seconds that we get here another call home. So let's switch back here to our virtual machine, and so here's the traffic, and at the moment I'm wondering a little bit. Yeah, this is the traffic that I wanted to see so far. And the next thing is, let's do something with the infected device. So for example, run a PowerShell command and simply say, who am I? So and just wait a couple of seconds if we see some new traffic here. And we see that DNS transfer was finished, and the output from the PowerShell whoami command is here simply the name of my machine and the logged in user. And this is all that we need to know so far. So I think we can stop capturing here. And let's look a little bit more about the suspicious looking DNS traffic here. So let's copy why not to summarize as text. Get here to a secret editor, copy and paste that block. Then we want to copy and paste the next block. And we also need this block here. So and then we can get rid of all the start information here, get rid of that line, and we also get rid of that line, and get rid of the postfix here, and then join all the stuff here together. So let's copy and paste that. Then I will leave the virtual machine. Then let's open here on my another machine the Cyber Chef, which is a great tool to investigate some stuff. So if you look at that by gibberish, yeah, and this is or the theory behind that is to obfuscate some traffic, yeah, and to transfer some information over DNS out of a network. So that it's quite common technique in, I would say, malware or in malicious traffic. So therefore the name malicious traffic. And if we get rid of the postfix and of the prefix here, you see that looks something like maybe a base 64 encoding. Yeah? So the first thing is here, do some base 64 decoding. And the next thing, or the next crucial information was part of the challenge description here. Yeah? I only know that my key was bad. And a usual or a common technique to obfuscate values or some stuff is XORing values. And if we try to XOR here as another receipt, or as another another command to run, and if we try that here, you see in this session this is just gibberish. But if I set here the right XOR key, which is here the queen, which is the default XOR key from the Queen's offensive framework, you see this is the output, and this is the information that we have transferred over DNS out of the network. And with all that information in mind, you should be able to crack or to deobfuscate the traffic and reveal the flag. Just keep in mind what I've said so far. Read the challenge description again. This is your key. You have now seen how you can deobfuscate all the DNS blocks. And maybe in the future I gonna create a video about the algorithms and all the other stuff that is working behind the curtain. But hopefully this is enough for you to solve the challenge. Thanks for watching, and hopefully see you in the next one.